Given an unsorted array of integers called nums, we must return the length of the longest sequence of consecutive elements. For example, if this is the array of integers given, then the longest consecutive sequence starts at 1, then goes to 2, then 3, and that's it. That's a total of 3 numbers, so we would return 3. Now, one way to solve this is to first sort the array. Then we could just traverse the entire array in order and keep track of the longest consecutive sequence that we're able to find. This approach works, but the problem is that sorting runs in O of n log n time, and this problem challenges us to solve it in O of n time. So if the array can't be sorted, then that means we have to figure out a way to look up each element in constant time. We can do this by turning this array of numbers into a set of numbers. Remember, a set is unordered and it's created by generating a hash code for each value using a hash function. You can think of the hash code as sort of like an index. And so if we want to check if a certain element exists in a set, we can just compute the hash and jump straight to it. Because of this, looking up values in a set runs in constant time. Now, if you're familiar with hashing, then you know that there can be hash collisions, which is when the same value maps to the same hash code. In the worst case, all of the values could map to the same hash code and the lookup time could degrade to O of n. However, if you're using a good hash function, then collisions will be very rare and the scenario we just described is extremely unlikely. So when talking about hash tables or hash sets, we usually say that the amortized complexity is O of 1. If you want to know more about this, then I'd encourage you to look up what amortized analysis is. But the big picture idea is that when using a good hash function, such as the one built into Python, collisions are rare enough that we can pretty much just treat each lookup as running in constant time. So now that we're using a set, if I want to see if the number 1 exists, I can look it up in constant time and verify that it's there. Next, I can also check for 2 and then check for 3. Then, when I check for the number 4, I see that it's not there, so I know that the sequence had a length of 3. And I was able to do each lookup in constant time. Now let's use this idea and solve this problem in Python. Let's say that this is the nums array. The first thing we're going to do is create a set from the array and call it numset. This runs in O of n time. Then we'll create a variable called length and initialize it to 0. Length will keep track of the length of the longest sequence that we're able to find. Then we'll enter a loop that traverses through the nums array using a variable called start. So initially, it'll take on the value of 1. Next, we're going to check if start is the start of a consecutive sequence. If it is, then we'll try to find the next number and keep the sequence going. And the way we'll test that is to check if start minus 1 is in numset. Right now, start minus 1 is 0, and as you can see, 0 is in the set. This means that 1 is not the start of a consecutive sequence, since we could start at 0 instead. That makes this if condition false, and so we'll actually skip this number and move on to the next one. Start is now 0, and 0 minus 1 is negative 1. Negative 1 is not in the set, which means that 0 is the start of a consecutive sequence. So now let's enter this if block and see how long this sequence can go. We'll create another variable called end and set it equal to start plus 1, so that's 1. Then we'll check if end is in the set, and if it is, then we'll increment it and see how far we can take it. So right now, end is equal to 1, and 1 is in the set, so let's increment end to be 2. Then we'll check again. 2 is in the set, so let's increment it to 3. Now when we check, we see that end is not in the set, so our consecutive sequence has ended. So we'll exit the while loop and calculate the length, which is going to be end minus start, since we're including the start value and excluding the end value. So right now, that's 3 minus 0, which is 3. We're then going to take the maximum of that value and length, so that the length variable holds the longest length that we've encountered so far. The maximum of 0 and 3 is 3, so let's update length to be 3. Then we'll move on to the next number. Start is now 4, and 4 minus 1 is 3, which is not in the set. That means 4 is the start of a consecutive sequence, so let's set end equal to 5 and see if 5 is in the set. 5 is not in the set, so our sequence has already ended. 5 minus 4 is equal to 1, since the sequence consisted of only a single number, which was 4. 1 is not greater than 3, so length stays at 3. Then let's move on. 8 minus 1 equals 7, and 7 is in the set, so 8 is not the start of a sequence, and we'll skip it. Next, 6 minus 1 is 5, and 5 is not in the set, so we found the start of another sequence. End will be 7, and we see that 7 is in the set. So let's bump that up to 8, which is again in the set. So now let's try 9, which is also there. But now when we try 10, 10 is not in the set, so let's see how long that sequence was. End minus start is 10 minus 6, which is 4, which beats our current length, so let's update length to be 4. Next up is 2. 2 minus 1, which is 1, is in the set, so let's skip that. Next, 9 minus 1, which is 8, is also in the set. And the last number, 7 minus 1, which is 6, is in the set as well, so we can skip all of those. We've now reached the end of the array and traversed all the sequences, so the only thing left to do is return length, which is 4, since the longest consecutive sequence was 6, 7, 8, and 9, and we're done. And remember, each one of these set lookups runs in constant time. We have an outer loop where start will loop over the entire array once. In the inner while loop, we would only get to this part if start was the start of a sequence, and for each starting number, end would traverse through the end of that sequence. So in other words, end will also only go through all the elements once. So if start traverses the array once, and end also traverses the array once, then that's a total of 2 end steps. But since in big O notation we drop the constants, this algorithm runs in O of n time.